SwayamPrabha. Digital India. Educated India.
Hello and welcome to the course on manufacturing technology theory and practice. So, in our previous session we have looked into the conventional machining processes. Let us start making the program. Well, again I am telling you that for the lathe, this is the x, this is the coordinate which is x, this is the coordinate with coordinate z. Similarly, in case of milling, if you see, this is z, okay. Z is in the cross slide direction and x is in the feed direction, that is the direction of the feed velocity, and y is vertically located with respect to the spindle if it is horizontal milling. Well, in case of drilling, it is the x in this direction, y in the cross slide direction and z in the vertical direction. For some reason this is internationally accepted, and everywhere wherever there is a CNC machine and the NC machine in service in practice, this is the axis or the system of axis that is used for turning, for milling and for drilling. Now, let us come to this. Keeping this in mind, of course, we are going to make the program for turning. So, we will keep in mind that this is x in the feed direction and z in the cross feed direction and z in the feed direction. Keeping that in mind, let us see how to program it, how to make the program manually. Well, first of all, the programs are made with blocks. Okay. Each block has some information about the tool, about the machine, about the cutting parameters, well, and how the machining has to be performed, including the coolant, on off, turning of the spindle in the clockwise direction or anti-clockwise direction and so on. So, all details will be given in the blocks and the program is made block wise. So, the block number is given by a letter N, capital N, as you can see here, and we will start a series, that is 5, 10, 15. Of course, it could be 5, next block is N6, next block is N7 and so on, but we are using N5, N10, N15, N20, and normally also this kind of a series is used because after the program is made, in the simulation if you find that something is wrong and some steps have to be inserted, for example, if you have taken N5 and the next is N10, so in between still you have provision to put N6, N7, N8, N9. But if you have N5 and N6, then of course you cannot insert in between because there cannot be N5A or N5B. That is the reason why we have taken N5, N10 and so on. Okay. So, this is the block number. First we will take T0101. 0101 means the 01 is the tool number. So, we will show you when we will show you the machine, I will show you how these tools are located in a turret head. Turret head is a bank of tools where different kind of tools are located. Let us say for turning, all right, on a turning lathe we can use different kind of turning tools, single point cutting tools, we can use grooving tools, we can use putting tools, okay, and we can also use the drill, we can use the boring tool, all right, and we can also use the chamfering tool. So, those tools are different tools, okay, meaning that with a putting tool, for example, you cannot remove the material along the on a cylindrical surface. Okay. Or for example, with a threading tool you cannot really part or make a facing operation, for example. Okay. So, therefore, all these tools have to be made ready for the operation, and all these tools are actually kept in a turret head. On the turret head there could be 10, 15, okay, even more than that, depending on the size of the machine, different kind of tools along with the tool holder. For example, if it is a drill, it will be inside the drill holder or the drill chuck, and the entire drill along with the drill chuck will be taken out from there and it will be put it in the drill chuck of the machine. Okay. We will show you that. So, that can be taken out and inserted in the machine by using a tool changer, okay, and that tool changer should be programmed. Okay. So, whenever we are telling that this is T01, that is tool number 1 in the turret, we are also giving the command to the tool changer that it has to activate, it has to be activated to take the tool number 1, okay, from the turret head and then keep it to the spindle. And next 01, you can see that here it is T0101. So, next 01 is the offset value. Offset value is the tool will not immediately touch the workpiece, but it will be offset from the workpiece at a certain distance. Okay. So, we are now preparing the machine for making the process here. Next, okay, after that there is a semicolon, if you can see. So, this semicolon means that this is the end of the block. Okay. Here semicolon is the block end. Next block starts after that. So, you have to have a number. So, this number is N10 as I said, and the comments are given as the G71, G90, G95, S1000, F.1 and M04. So, these are the codes. G is the G code, there is a series of G codes, and that series will be from G00 to G100. So, 101 different G codes are there, and each code means something. I will show you that table where these G codes are tabulated, and you do not have to remember all of these, that is not possible. You will always have a handbook while making the program for a particular part on the NC, for the CNC machine. So, that table can be readily used, and you can see that if you need, for example, some system that is to be used for data input. For example, here it is G71. So, in this case it means that we have to use the metric data input. Okay. The data that we will be giving, all these data will be in metric system, meaning that we do not have to put the unit after the value, and it will be assumed that that unit will be in the metric system. So, that is indicated by the G71. Now, in the NC and the CNC machine, after the program is input, that program is read and translated by the machine control unit, MCU it is called, and the machine control unit is the brain of the machine, which will actually try to understand what, for example, what G71 is or what G90 is. It is all embedded there. As soon as the MCU or the machine control unit looks at G71, it will automatically understand that, well, now everything I should understand that the dimensions are in metric system. Okay. And accordingly this MCU will translate and it will give the signal to the actual machine, to the hardware, what to do. Okay. So, here it is the metric data input. Next is G90. G90 is the absolute programming. So, as soon as the G90 code is given, the MCU should understand that this is the absolute programming. Absolute programming means the following, that if you look at this dimensioning in the part, the dimensions are made based on this surface, all right, on this plane. You can see that from this plane all the dimensions are given, like from here to here it is 2 millimeter, okay. From here to here it is 17 millimeter, from here to here it is 32 millimeter, and so on. Meaning that here it is all the dimensions are from the base, and the base taken as the plane which is here. Why it is that? Because we have selected this point on that base, on that surface as the machine 0, that is 0 0 coordinate. We have assumed that this is 0 0 coordinate, and that we are actually telling the machine that we have taken this as a 0 0. Okay. Now, I will tell you how we are telling that to the machine, because in the program so far we have not seen this. Only thing is that the G90, the program, the MCU will understand that all this will be based on the absolute programming, okay, from a certain base, and that base it will try to find out where is the 0 0, where is the machine 0, all right. Now, the next code if you see is G95. G95 is the feed per revolution, okay. So, feed per revolution in the sense that here it is this feed is millimeter per revolution, this is the feed value G95, and this feed will be in millimeter per revolution. S is the RPM, that is the rotation of the spindle, rotational frequency of the spindle. This is given by S is a speed, and speed given is the 1000 RPM. See, the RPM we are not writing, but we are giving the G95 because G95 said that this is the feed, and feed will be millimeter per revolution. So, then that means this S will be in revolution, although we have already said that this is in the metric data input, and therefore, it has the program will assume it. F stands for the feed rate, this will be in millimeter per revolution, and the value is, here we are giving the value as 0.1 millimeter, okay. And then it is M04. M is another code like the G code. M code stands for the miscellaneous code, okay. Here the M04, for example, it is the main spindle on counterclockwise. So, in the table you can find out what is M01, what is M02, M03 for example in the clockwise direction, M04 is in the counterclockwise direction, and so on. So, each code tells the MCU that this means that the hardware has to do something in a certain fashion, that is all. And all of these codes are available in the table, and each code, what does each code mean is given in the table. So, therefore, you have to just find out that how the tool has to move initially, okay. That it will be your decision, and accordingly you put that path or the pattern of movement of the tool in terms of those codes which are already tabulated. Let us take the further example in the next code, next block we have the N15, which is G00X26Z2. Now, this means G00, this is the rapid traverse, okay, rapid movement of the tool. Since the tool is somewhere parked, okay, and we are not bothered about where it is parked, because it is decided by the manufacturer, all right. The tool is safely parked somewhere, it is away from the workpiece, away from the spindle, so that it is not harmed, okay. Then our task is to bring the tool to a position where it is ready for making the part. You see that we have given the program, we have given in the program G00, this is the rapid traverse of the tool, and the coordinates we have given as X26, that means in this axis 26 millimeter, and Z axis, along this Z axis it is a 2 millimeter, all right. So, that will be with respect to the point 0, 0 0. So, if you see that it is 26, 26 means it will be just above the part, okay. Here it is 20 millimeter diameter, we are putting that safely in the at 26. So, the tool will come from the parking to the safe position, okay, at a point where the tool is still not touching the workpiece, but it is close to that. So, it will be at 26 and above this part by 2 millimeter. So, away from the part by 2 millimeter, Z is 2, Z is in this direction, all right, this is understood. Here we are saying that this will be the reference point where we have, to which point we have called the tool from the parking. Okay. Next we have to give we have to start making that. We are giving the next program, next code is G01 and Z minus 0.1. So, we are saying that this is G01 means the linear interpolation. A linear interpolation, in one word I will tell you linear interpolation in little more details during the lecture sessions. Right now you should understand the linear interpolation when the tool has to move in a linear way, all right. So, it will not go according to the curve of any curve, it will go just linear, either along the x axis or along the y axis, or with both the axes together in an inclined path, but the path will be linear path. Now, we are saying that Z is minus 1 with this. So, it will come from that at a distance which is very close to this, that is 1 millimeter away from here, okay, because Z is in this direction. Next we are saying that here it is x, we are giving now minus 0.1. That means it will take a depth of cut and it will try to move an x as minus 0.1. Okay. So, at this distance, and it will try to face, it will remove the material from here, and the tool will be moving at x, because if we put the x and z together, it will be a tapered surface, because both on x axis and z axis the tool will start moving. As a result, you will see that this is not a straight, but it is a tapered surface. So, therefore, z is given separately 0.1. So, the tool is brought rapidly to this place, and then we are giving a value which is 0.1 in the along the x direction, and then the tool will start moving. By that also the tool will be removing the material. So, it will be facing, tool will move perpendicular to the axis of the workpiece and it will face this surface. Okay. So, this is the facing. Next we are saying the G00x26Z2. So, you can see that this is the same command as here, meaning that after facing, after it completes the facing, it will go back to our reference point, and the reference point will be using as all the time 26x and Z2. This is a safe position for the tool, that we have brought the tool to the reference point from the parking point. All right. Next code, that is next block, is the G73 U1 R.5. Okay. So, here the 73 is the stock removal in turning, and stock removal in turning, this is the somehow it is used in the official word of the CNC manufacturer, okay, but this is actually the contour turning cycle. Contour turning cycle is that when the tool will be moving like this here along a contour. Okay. This is when the tool is moving along a certain contour, the MCU has to understand that this should be G73, or rather if we are giving G73, the MCU will understand that the tool has to move along a contour. What is that contour? It has to take U1, U is the depth of cut, and depth of cut will be that incrementally the tool will take always 1 millimeter of depth of cut incrementally. That means 1 millimeter it will take, move along this profile, okay, and then it will go up and again come back, take in another 1 millimeter and move along the profile and so on. I will show this movement in the machine as well as in the simulator after this discussion. R is 0.5, that means R is the retract height. As I said that it will take the 1 millimeter depth of cut, move along the profile, retract, go back by 0.5 millimeter, okay, and then again take 1 millimeter depth of further 1 millimeter depth of cut, again it will go. So, all these movements are the different passes, as you understand. These are the rough passes, all right, and in each pass it is taken a depth of cut of 1 millimeter incrementally. Each time it is moving along this profile, it will take a depth of cut of 1 millimeter. That is how this program says. G73 profile movement of the tool, U1 is the depth of cut 1 and R 0.5 which is the retract of the tool. Okay. In the next block we are saying, interestingly, just look at it, this is also G73. Then we are saying P45. Okay. P45 means block number of the first block of the program shape. Let us go to 45, this is 40, N40. P45 means you go to 45, okay. Whatever is the program and whatever is the action given, you do that here. Similarly, after that it is a Q75. Q75 means that 75 block of the last block for the program shape, okay. Meaning that how this shape has to be made, each of these shapes will be given in different programs, 45, 75, okay. And each time this is made, it is supposed to take a finishing offset of 0.2 in the x direction, this is u, and the finishing offset in the z direction is 0.2. Okay. Mind one thing, this is the finishing offset in x direction given as u, this is not the same u as in here. Now, of course, it can be little confusing that both are u, but u in this case means the depth of cut and here the u means the finishing offset. Now, mind it, when this u will be associated with G73 particularly, it will mean that this is the depth of cut, and if the u is associated with the G73 in the blocks, when the blocks are being recalled, then it has to be the finishing offset. So, finishing offset is 0.2 millimeter is taking for the finish cut, and W 0.2 is the finishing offset in the z direction. So, it means that when the profile is made and final cut, finishing cut will be with a depth of cut of 0.2 in the x direction and 0.2 in the z direction in both the perpendicular directions, that is this direction is the x direction, this direction is the z direction. In both the directions 0.2 millimeter has to be taken and the entire profile has to be made in as a final shape. So, therefore, the N45 you understand that N45 will be first point coordinate for turning here, all right, and here the coordinates are x12 and z0. Z0 is here and x12 is taken, see here for example it is x12. So, this is the 12 millimeter diameter, you can see that, right. This diameter is 12 millimeter, therefore, this is 12 millimeter and z is 0, okay. From here we are starting. So, in this direction there is no movement, but in this direction it is making 12 millimeter of the facing. Second point coordinate for turning is coordinate given in the block number N50 as x14 and z minus 2, x14 here, z minus 2. Now, it is a movement here because when this was made z was 0, when this is made minus 2 has to go and the diameter is 14 millimeter. Similarly, the next third point will be z minus 17, z that is in this direction, that is minus 17 millimeter, the tool has to move by, and while moving, of course, it is assuming that this movement is for removing the material, all right. So, it will go through the material of the workpiece and therefore, this 17 millimeter as it is given is here. Then x20 and z minus 32, you can see this minus 32 and 20, so and so on. So, that means all these profiles, okay, up to this N65, this will be the points coordinates of each of these points, so that the tool can move along this profile, okay, along this profile with certain allowance initially for making the rough paths, okay, and then final path with the final 0.2 millimeter of the depth of cut, it will give the make the final contour shape. Okay, we will see this. Now, next in the 70, it is the G02, that is x24 z minus 40 r5, for example, it is this, right. We have to give the radius, and G02 is the circular interpolation. If you remember, we had the G01, it was the linear interpolation, because tool was moving, a tool was to move in all these cases up to this point linearly, but from this point to this point the tool has to move in a circular path. So, this is the circular interpolation. We have to give the comment to the tool that it has to move no more, it has to move linearly, but now it has to go in a semicircular way, all right. That is the circular interpolation. Now, circular interpolation, particularly the G02 stands for the circular interpolation in the clockwise direction. So, it will move like this, because as you can see the tool is here and it has to make a movement like this. So, it will be in the clockwise direction. Okay. Coordinates are given x24. So, you can see that 24 millimeter is the diameter here, okay. This diameter is 24 millimeter and this distance will be z minus 40. So, this is the distance, right. This is 40 millimeter, sorry, 40 millimeter is the distance from here to here in the absolute dimensioning, and the diameter is 24 millimeter. So, this is the comment, that is we have tool has to move a circle, make a circular interpolation, and the coordinates given as 24, 40 in the z, and the r5 is the radius of this circular interpolation. Next comment is the G01. This is the last point coordinate for turning here, okay, 43 here given, this is the Z43, and then G72 is the finishing cycle. So, from first point to last point, this is the finished G00, and the coordinates given x50, Z50, tool away from the job. After it does it, the tool will go away from the job and it will move up to 40 millimeter, which is more than 43. So, away from the workpiece, as you understand, and similarly Z also will be 50. So, upward it will be 50 millimeter. Now, the G28 is approaching the coordinates of the intermediate point U0 and the W0. These are the intermediate points where the tool will be going. Okay. Next is the tool calling for grooving. So, now we have to change the tool, because so far with the same tool we have made this circular interpolation, linear interpolation, chamfering, okay. But for making the groove we have to have another tool. So, we are telling that we are taking the tool as T06, 06, okay. So, this is the tool for the grooving. Next block is 100, N100. Here the comments G code is 95, speed is 1000 rpm, M is 04, is the main spindle in the counterclockwise, okay. S I have already explained to you earlier, this is the rpm, all right, and the value given as 1000, like it was given earlier also, it was S 1000. Next block is G00, that is the rapid movement in the direction in the coordinate x 15 and z minus 15 it is coming, okay, some distance away from here, because it is 14 millimeter, it is coming up to 15, little more, all right, and z also minus 15 in the z in this direction, and x also in the 15, that is in the diameter 15, and here if you see distance is 17 and here it is 12. So, it is somewhere in the 15, that is what it said. Next is G77 R1, this is cut in cycle in the x axis is in here. So, this is to be, this is a grooving tool we have already taken T06. This grooving tool has to move to make that groove in the direction perpendicular to the axis of the workpiece, that is in the direction of the x axis. So, therefore, we are giving the giving the value as x 12, because as you can see the diameter is 12 millimeter and z is minus 17. Here is the value of the z, P 200, Q 1500, F 0.05. Now, this P and Q associated with the G 77, which is the cut in cycle. G 77 means when along the x axis the cutting process is in cycle, x axis is here, that means the tool will move like this only, right. So, in this we have to give the cutting depth, and for the putting tool depth is very small, because otherwise the tool will break, you understand that, and it is as if it is a putting tool as in case of putting the workpiece. So, tool will move like this, and each time it is taking the depth of in the x direction as 200 micron, and incremental feed in the z direction as it is moving, it will also move in the z direction to make the width, because here there is a certain width of the groove. To make the width, it has to have the incremental in feed in the z direction, that will be in micron also. So, each time it will move at 1500 micron, and then F is the feed taken as 0.05 for the tool. Tool width is 3 millimeter, that has been assumed here. So, exactly 3 millimeter will be made here in case there is no feed given, but depending on the width given for this groove, you have to have the feed supplied to the tool. Next is tool away from the job, which is given as G00 rapid movement. This is in the block number 120, and we are keeping it to the x50 and the z0. This is the approaching the reference point, all right. Then we are next is G28 approach the reference point, okay, and here it is the coordinates, and these coordinates are the same as we have taken the tool here. For example, if you see the N90, this is also U0 W0, the same way we are taking the tool to the reference point, okay. Now, next is the threading. So, this threading is M 14 into 1.5. Now, we have made the groove, okay, at the diameter of 12 millimeter, then we have to make the thread, all right. So, you understand that a nuance, that why this threading is done after we make the groove. See, if we did not have the groove, in that case making the thread would have been difficult, because tool that is used for making the thread needs an exit from here, okay. After it is cutting the thread, it needs an exit. So, without that groove, that exit of the tool we could not get. So, therefore, first the groove is made, and then the thread is made, so that the tool can have an exit, okay. So, for threading we are taking another tool, which is 03. So, 0303 will be the threading, all right, and here we are taking in the next block G95, okay, 5S 200 and M03, okay. So, G95 we are using it here, that is the feet per revolution, the same will be here, feet per revolution, and speed is 200 rpm, okay, and M03 is the main spindle in the clockwise direction, that means the right hand thread. For clockwise direction, when the main spindle is moving, we are having the right hand thread cut in the along this length of 12 millimeter, okay. Next is G00 rapid movement in X14 and Z2, tool calling point for the thread cutting. We are calling the tool, but it is rapid because tool at that point, when it is coming to this point, while coming from another point, it is not removing the material. So, it can come at a rapid movement very fast, so that the time taken is less. Next comment is G78. G78 is comment means, according to the table, it is multiple threading cycle. That means it will cut the thread and then it will again cut the thread, going back, again coming back. So, it is multiple threading, all right. So, that each pass, okay, will be a rough pass, and finally, the depth of the thread can be achieved, okay. That is given as the G78, and P030660. As you can see, P means P03 is the finishing cut, that is the comment. Now it is 06, 06 is the chamfer value, okay, when the tool to be retracted. So, the tool is cutting and then it has to be retracted, then again it will come back and again go back to cutting the same way with the different depth with an additional depth of cut. So, this is given here. Flank angle of the thread is given as 60 degree here. Flank angle of the thread is this is the thread. So, this is the angle which is the flank angle of the thread, equivalent to the cutting angle of a tool. See, the tool will actually conform, tool shape will be conformed to the thread. Okay. So, if the tool is having, for example, a shape like this, the thread also will have a thread like a shape like this, meaning the tool is like this. Okay. Tool is moving and it is moving towards this direction as well as moving towards this direction along this profile. So, this angle is the flank of the thread. Okay. Now, this angle is specified in case of in here, and then Q50 stands for minimum cutting depth, which is incremental in micron. That means, how much depth it will be taking minimum, not more than that. Okay. In incrementally, incremental system I already told you that each time it will take once and then again and that is incremental. So, then R is 0.01, which is the finishing offset, that is also incremental. Last cut will have with a offset of 0.01. Then we will have the G78, again the multiple threading, okay, with the root diameter of the thread length is given minus 14. So, because it is the M14, all right, and R0 is the incremental taper value, we have already said that here. Q value we have already said, cutting depth per for the first cut, that is in micron. Okay. Then we have the P805, this is the thread depth, 805 will be the in micron, and F is the pitch of this thread. Okay. From one peak to another peak is the pitch of the thread. N155 block, after the 150, it is a rapid movement along the coordinate x50 z50, that we are taking that in the safe safe position. Then the next block we have the approach reference point, we have taken that here like in 125, like in 90. Okay. So, then it is coming to the reference point, and then it is the end of program is M35, M30. M30 stands for the program ends, that means now the tool has to stop and the machine will be switched off according to this program as M30. Machine will understand, or MCU will understand, that the command is given that after that no other operation will be performed. Well, as I was telling that there are different kind of codes. Here you can see the M codes. So, M codes are also many, which is the miscellaneous function, and each one of them stands for something. For example, M00 is the program stop, M01 is optional program stop. So, miscellaneous program is that you are preparing the machine. Okay. Each of them you can see that for preparation of the machine, how the machine will start making the process. Here the address words used in the NC, you can see that these are 26 alphabets of English, and from A to Z each one of them means something. For example, A is the rotation about the x axis, B rotation about the y axis, C rotation about the z axis. Now, these are the tables which are standard tables, which are international standard, and any machine used in any country of the world will understand the same codes, if of course the system is the same used. There are different systems used, and the one that we will show it to you is the Fanuc system, which is system made by the Japanese, and in that these codes which are embedded, meaning that if you give the A, for example, the machine will automatically understand that this has to be rotation about the x axis, all right, and so on. So, here you can see we have used that S, you remember S, we had the spindle speed, we have used the U, this is the supplement coordinate parallel to x axis and so on. Okay. Data given are x, y, z. If it is x given, x we have seen in the program it was given, for example, here it is x 14. So, along the x axis it will be 14 millimeter, x axis is here along this, all right, and so on. If it is z, meaning that along the z axis it has to be the value given. So, these are the values which are given here, that is the data, x axis data is given by x and so on. Similarly, you can see the M codes. So, what I mean to say by showing you these tables is that all these are available with you and you do not have to really remember each of them, but you can always use these tables while making a program, all right. Suppose you have to move the you have to rotate the tool, rotate the workpiece along the x axis. So, you have to use the program in the program A and so on. So, you can find out. Of course, when you will make the program very frequently, you will get used to some of the codes and you will remember some of the codes. Okay, I mean G00 probably you already remember, this is a rapid movement because we have used so many times the G00 and so on. Here are the G codes. Okay. As I was telling that G00, this is a rapid linear positioning. Okay, so, rapid movement of the tool in one word. And similarly, from G00 to G99, these are the 100 codes, G codes. Okay, these are popularly known as the G codes, and these G codes are used for functioning, some functioning or other. For example, clockwise circular interpolation will be G03. Okay. Clockwise circular anti-clockwise, clockwise circular interpolation will be G02, linear feed interpolation will be G01 and so on, so forth. So, all these are given by the G code and these codes are embedded in the program, and the program, as the program is given in using one of these codes, MCU, which is the machine control unit, will read and understand what it is required from them, and accordingly it will send the signal to the hardware, to the machine, that what to do, okay, how to move along the x axis or z axis. So, accordingly the signal or the voltage will be given to that particular prime mover which is connected to either x axis or z axis to move the x axis and z axis according to the program, or moving both the axes together to get a taper surface or inclined surface, some kind of an inclined surface and so on. List of M codes vary from machine to machine depending on the functions available on it. Here are some of the popular M codes function. M, as I said, that these are the preparatory functions. Okay. They are decided by the manufacturer of the machine. The M codes listed below are, these are the very common. For example, spindle tool change is M06. If you have to stop the spindle, it will be M005. Okay. Program end is 98, subprogram call, and 99 is the subprogram end and so on. Okay. So, if you have to end the program, it is the M99 or M98, you are calling that. End of program is M30, that we have already seen, that is the end of program reset to start. Coolant you can put on or off. Okay. For example, if you have to put the mist coolant, okay, this is M07. If you have to put the flood coolant, it will be M08. So, you understand that different kind of coolants can also be used to switch on and switch off by using one of these codes, and these codes are understood by the machine control unit. So, whatever we have seen so far is an example of a turning. That means, we are using the turning lathe for making this. So, it is the CNC turning lathe. Similarly, we can have the CNC milling. If you see this slide, here we have one part which is a very simple part for that matter, which has the A, tool goes to B, then C, then D, E, F, G and H. So, this is the movement of the tool which has to be made, which has to be programmed with a circle at the in the middle. So, if you see now I will go little quickly, because this will be to a large extent repetition of some of the codes which we have seen in the case of the turning. For example, G54, so block number, okay, and it is the 0 offset. Earlier we have given some offset, so it was some value was given. Tool number in turret is 0.1 we are calling, okay. Here in this case of course it will be milling cutter, and M06 is the tool change, so tool has to be changed to 01. G43 is the tool length compensation. This is something which I have to explain it to you. It was not there in case of the turning, that is the tool in this case is a milling cutter, okay. In the case of the turning, it was a turning single point tool. So, the tool point was exactly touching the workpiece. In this case what happens is that milling cutter has a diameter, okay, and all the movements of the milling cutter along the profile, for example, in here the milling cutter will move from here to here, let us say from B to C, then here and so on. So, these movements, okay, of the milling cutter is as far as the axis is concerned. That means, this is the movement of the axis, that means what the periphery will be moving, that means it is the radius of the milling cutter, that much compensation we have to give for the movements that we are planning, so that at the periphery away from the axis of the milling cutter, okay, that much is tool to be compensated, that is the along the diameter. Similarly, we have to give the compensation along the length. Along the length means, suppose we have again the tool which is the end mill cutter, okay, vertically it is milling. So, when this tool is touching, what is touching is again not the center, and to have the center, assuming that it is touching this point, we have to give some kind of a length compensation. So, that is given by the G43, either it is a length compensation, or we will see later on that it could be a diameter compensation as well. In this case, it is the length compensation that we are giving, which is given by G43. Well, the length compensation I will explain it in a different way, which is popularly explained in our lab to the students. Let us say we have different kind of lengths in the milling cutter, okay. This is one length, this is a bit bigger, this is little smaller, but it is still bigger than this, and so on. They are all different. Now, when these tools will be touching, suppose we take the reference point when this tool, which is the largest length, it is touching. In that case, for this tool it will not be sufficient, okay, it will be less, and so on. So, therefore, each tool is touched, and that point for that particular tool is recorded as 0, okay. So, that will be expressed as the tool compensation or the offset, okay. So, this is the tool length compensation, and offset value for tool length compensation is H1. So, this is some kind of a value which is given to the tool offset, so that the tool length, so that the length can be compensated. In the next module, block, N15, this is G94. G94 is feet per minute. If you remember, in case of turning, it was feet, it was per revolution. Here it is milling, and as you understand that feet is given in feet per minute, okay, millimeter per minute, all right. So, therefore, the code is G94. In case of the turning, the code was different, it was millimeter per revolution. Feet, this RPM is given for the milling cutter, okay. Feet is given 100 for the millimeter per minute, because it is already said that it is millimeter per minute. So, as you say F 100, it will understand that 100 will be millimeter per minute, and then M03 is the main spindle moving clockwise, all right. So, the further I will discuss in our next discussion session. However, you understand that the programming principle will be similar to the one that we have discussed in case of the turning. That means, we have to ultimately move the tool during in all these, along all these points, and come back here, so that the entire profile can be made. We have the N20 block. N20 block says that we have to have the rapid positioning of the tool. Rapid movement is given by G00, and coordinate is given, that is x20, y20 minus 20 and z minus 20. Mind it, this is milling cutter, okay, movement. So, it is on the milling machine, and in the milling machine the z direction is this, x direction is this, and y direction is the cross, okay, like coordinate system. So, therefore, x, y, z, do not get confused with the x, y, z of the turning. In turning we have the x and z, all right, there is no y movement, and here we have the x, y, z, because the table movement with the workpiece can be along the x and along the y, and along the z axis the tool will be moving, that is the spindle with the milling cutter will be moving. So, here it will be all 3 x, y, z. Now, z20 in air, and you understand that this is the x20, y20, the tool is positioning here, okay, at this point. So, this point coordinate is A, and along the z it is 20. So, it will be just above the point, above the workpiece. So, it will not be touching, it is on the air, and it is away from the workpiece by 20 and 20 in the x and y coordinates accordingly. Next block says G41, G41 H11. G41 stands for the tool radius compensation, okay, and the tool radius compensation is, I already told you that the periphery is cutting, but the dimensions are given with respect to the axis. So, therefore, the compensation has to be given, and H11 stands for the offset value for the tool radius compensation. Okay, what is the value for tool number 1? All right. N30 block given G01, which is the linear interpolation, we have seen that earlier, and this is x0, y0, this is positioning B. So, let us say we have made this point as the machine 0. If you remember, I will come to this turning point once again. We said that this is the point, if you see the diagram here, this is the point on the workpiece which we have made as the machine 0, okay, that is the 0 for us, whereas manufacturing 0 or the manufacturer's 0 point, reference point, and then intermediate point, then the parking point, and so on, that's there is a different. We have made a point of, we could have made it here, that depends on you. In that case, you have to make the machine understand that this is the 0 point, then with respect to this all the dimensions would have been given. Okay. You understand the difference, that you are this is made by you, the user. User is saying that, okay, I will make the, for me it is convenient that this point should have been 0. Okay. In that case, based on that line, okay, on this, let us say here also you can see that this is 0 0. So, based on this line, which is this surface, all the dimensions are given. So, it is an absolute dimensioning. Similarly, in case of milling, here we have made as a 0, okay, and this is the tool position x0, y0, all right. Now, next block says move z to minus 3, this is the depth of cut, and this is in here, it will go little deeper, okay, with the 3 millimeter of the depth. This is the depth of cut given. This is the tool position which will be, let us say B1, that means it has gone below the B with a 3 millimeter of depth. X33 in the 40th block, this is the position C. So, you can see that this 33 is the dimension 38 minus 5. So, this will move up to, from here to here it will be 33 millimeter. So, this is what it is given, that x direction, and as you can, as I said earlier also, that this is direction is plus. So, as the tool is moving from here to here, and mind it, this is the axis of the tool, we have already given the compensation, okay, radius compensation and the length compensation. So, according to that we can assume now that the periphery of the tool, that is the tool cutting point in the milling cutter, is actually removing the material and it is moving while moving from B to C, and this distance is given as 33 millimeters. So, now the position of the tool is C. Now, from C to D, to move it x 38, okay. This is the tool position here with the linear interpolation x 38, and y is equal to 5. So, this is the 5 millimeter, it will move in here, and this will be the D position of the tool. Next is the x 38, again the linear interpolation, it will go from here to here, and the distance is again 33, 38 minus 5 from here to here, all right, from here to here 33. So, then the next from here to E position, yes, this position to E position will be 38 minus 5. So, this is 33. Now, next block is N55, which comment given is G03, which is the circular interpolation, because from E to F you can see that there is a radius given which is 5 millimeter. So, the tool needs to have a circular interpolation, like we have seen in the case of the turning, where we had the semicircular path of the tool, if you remember. And the tool position will be in F when the coordinates will be given as x 33 and y 38. That means, you remember that all these dimensions will be taken with respect to this point, okay. This has to be remembered. Now, when it is going to F position, then this distance will be from this point, and from this point this distance will be 38 minus 5, this is 33, and y is 38, okay, 38 given here. So, this is the position of the F after the circular interpolation. Then it will have a linear interpolation with x 5 and y 38, it will come up to this, okay, up to this, and then we will have the circular interpolation here with the r 5 we have to tell, and the coordinates will be x 0, because if it is coming here, then x will be 0, and then y will be 33, this is the 33, and then the tool position will be in H. R 5 is given already for the radius of the arc, and in the next block we have the linear interpolation again from H to B, all right. This will be, when it is coming to this is the final point which will be giving from the H. So, it will be 0 0, because 0 0 it is coming back to the initial position, all right. Next is the Z2, that means from here the tool is moving up at the air, and it is tool position is somewhere the B2, which is away from the workpiece. Then the rapid positioning, it is going to the I position. I position is not shown here, it is in the Z direction, that is why, all right. And then it is the depth of cut, linear interpolation, and so on. So, what is shown here in the next comments is that from here the tool has to go to this point, all right. Tool has to get a depth of cut, and the tool has to make a movement like this. Then from J it has to go to the counterclockwise. Here it is clockwise, okay, the clockwise, and then it will be a hole will be drilled at the center. That is why it is given that the linear interpolation will be done with a Z depth of cut, it will go from here to here linearly. Then there will be a circular interpolation clockwise, all right, and the tool position will be somewhere in J, because it is coming from I to J, all right, and then it is again going and the circular interpolation clockwise from J to I, all right, and again the position will be I with the coordinate y 19 and x 19 and y 9. So, these coordinates will be x 19 and y 9, you can find out from the diagram, or it has to be given in the drawing, all right. R10 is the tool with a radius of 10 millimeter. This is a profile tool which is used to make this round shape or the drill hole. Then we have the rapid movement. So before that we have the 100 is a G01 linear interpolation, G40. G40 is the, now we are cancelling the radius compensation. The cancelling is done by G40, and 2 millimeter we are lifting on the air the tool, all right. Next is return to the reference point, and Z10 will be in the air. So it has gone on the parking, meaning that it has to go from here, from the, after drilling the hole, it will be lifted up and it will be taken to the safe point, so that the tool can be parked. So overall you can see that this has been made, all right, with this program. If you make it manually, and then this manual program will be given to the machine, and you will see that according to the program that is made, the tool will be moving along these points and this entire profile is made. Okay. So you use an actual tool, you use an actual workpiece with a certain material, okay, and we will show you in the machine that how these kind of programs can be written, can be run, and can be utilized to fabricate the program. How this profile is made, I will discuss in more details in our next class, next discussion level. Thank you for your attention.